Welcome back to a course on multivariable calculus. In this lecture, we are going to talk about the concept of limits. So, we have talked about the concept of limits of functions of one variable. We are now extending this idea to the several variable setup. Okay, let us recall what we have seen in the one variable setup. Initially, we had the function y is f of x. Okay, we say as limit x approaches c, when we apply this limit to this function, we are going to get some L. If we have to say so, what should be the case? For every epsilon positive, there exists a delta positive such that absolute of f of x minus L is less than epsilon whenever 0 less than absolute of x minus c less than delta. So this was the definition of a limit. Why we have excluded 0? It is because that when you say x approaches to c, if this is your point c and okay, when you say x approaches to a point c, your function may or may not be defined at that point. Okay, when the function is not defined at this point c, we cannot talk about f of c. So that is why in the definition of limit we omit x is equal to c. That case we omit. Okay, that is why we have excluded 0. This is in the one dimensional setup. Okay, here now let us see for the two variable case. Supposing this is our function. Okay, what is the domain and codomain of this function? This f is a function defined from some domain in the R2 to R. Okay, and here when you talk about limit, you will give the point xy approaches to some point x0 y0 to this function f of xy. It is going to be some value. What is f value? That will land in the set of real numbers. So extending the same ideas here, for every epsilon positive, there is a delta positive such that absolute of f of xy minus L less than epsilon whenever you have 0 less than absolute of xy minus x0 y0 less than delta. It is just the direct application of these things. Okay, if you have a closer observation to this is going to be a member in, actually this will land in the set of real numbers. L is also a real number. Okay, this epsilon is a very small positive quantity which is a real number. Okay, this delta is a real number, but this xy and x0 y0, these are coordinates. So when you have two coordinates AB and CD, okay, that is you have chosen 2 points in the plane. When can we say these 2 points are equal? This will happen only when A and C are same and B and D are same. That we know, right? And how do we find the difference of these two quantities? That is term-wise difference. Okay, if you have to add, then you will have to do the term-wise addition. Okay, so this quantity alone, okay, I am not writing for the complete definition, I am just writing this one alone, that is 0 less than absolute of x minus x0 comma y minus y0. What is the absolute value of a coordinate? This is again another question. That is distance from the origin to this point, that is going to be the absolute value. Okay, now is the same in one variable setup too? Yes, of course it is the same in one variable setup too. Okay, you have this as your I think if I draw in some other color, you can better understand these things. Okay, suppose this is your number line, this is your 0 point, I take 5 here. Okay, what is the distance of this 5 from the origin? It is 5 units. Am I right? I take minus 5. What is the distance from origin to this 5 minus 5? It is again 5 units. So you are not considering about whether you are traveling in a positive sense or in a negative sense. Just you are trying to identify the distance from the origin. Okay, the same ideology can be extended here. Absolute of a coordinate point is the distance from the origin to that point. Okay, so what is the distance between 2 points, that is x1 y1 and x2 y2? We know it is under root x1 minus x2 whole square plus y1 minus y2 whole square. This is the distance formula. Okay, here we have a point already, that is x minus x naught, y minus y naught, and the other point is 0. So this is going to be 0 less than under root x minus x naught whole square plus y minus y naught whole square. This quantity has to be less than delta. Okay, so when we considering all these things, now let us define the limit in a formal way. Okay, that is definition of a limit. So how are we going to do it? We say limit xy approaches to x naught y naught to the function f of xy is L if for every epsilon positive there exists a delta positive such that absolute of f of xy minus L less than epsilon whenever 0 less than under root x minus x naught squared plus y minus y naught squared less than delta. Okay, now you will have to see what is this thing. Okay, forget about the 0 and consider this part alone. Okay, this part in the sense under root x minus x naught whole square plus y minus y naught whole square less than delta. This may also be written as x minus x naught whole square plus y minus y naught whole square less than delta squared. Since all these are positive quantities, this conversion is very well valid. If you have a closer look at it, you may very well see if this is your point x naught y naught. Okay, around it you are going to fix a radius delta and you are going to find a circle. So this quantity covers only the points on the circle? No, it is not going to cover the points on the circle. It covers only the points inside the circle except the origin, because we have omitted this 0. Since this 0 is omitted, we are omitting the center of the circle as well. Actually, it is no more a circle, it becomes a solid, right? So we are circle means only the boundary is called as the circle. We are covering the interiors of the circle, which means we have a disk. Okay, so suppose this is your domain, in the sense you are identifying some disk like this, and where is your L? Where is your L? It is somewhere here. So around this L, you can have epsilon thing. So this definition tells you that, hope you people remember the definition of a limit in one variable setup. I have shown you the diagram. Whatever you have in the x-axis, the corresponding error area in the y-axis. So here it tells you that if you take any point on this disk, okay, if you take any point, just a minute, yeah. So if you take any point on this disk, You apply that point to the mapping and you have to see that that lands in this segment only. So that is what the definition tells you. So this will come from here to here. Okay, so through F you reach here. This is the definition. Now, what are we going to see? We are going to talk about the properties of limits. So here I am not going to explain in detail about the properties of limit. The sum rule, that is limit xy approaches x naught y naught to the function f of xy plus g of xy. It is same as that of applying limit xy approaches to x naught y naught to the function f of xy plus limit xy approaches to x naught y naught to the function g of xy. Okay, so the exactly the same result that we have seen in the one variable setup. Similarly, your difference rule, product rule, quotient rule. So when you talk about the quotient rule, you have to be very careful that your denominator has to be a non-zero quantity. And apart from this, we have the constant multiple rule. And what else? So the power rule, root rule. So when you talk about the root rule, you have to be very careful that it has to be some odd value so that it remains positive and the negative remains negative as it is. Okay, all these ideas we have dealt in the one variable setup and all these can be extended to multivariable setup. Here, these things I have explained you people for the two variable setup. If you wish to extend this to a three variable setup, yes, of course you can do it. That instead of a solid, you are going to have a what? A sphere with inside filled. Okay, you will have a solid. Here you had a disk, there you will have a solid, a ball. Fine. Now let us work out some problems in two variable only. So the first problem that we are going to do is we'll have to find out the limit xy approaches 0 comma 1 to the function x minus xy plus 3 upon x squared y plus 5xy minus y cube. So whenever we are given with functions like this, what we actually do in the one variable setup also, what we have actually done is that we were just trying to apply the given values. In the place of x, we'll apply 0. In the place of y, we'll apply 1. That is the primary attempt that we make. Okay, in that attempt, if we are able to get some finite value, we conclude that that is the limit. The same thing that we are going to do here too. So when you apply it, you may have 0 minus 0 multiplied with 1 plus 3 upon 0 squared multiplied with 1 plus 5 multiplied with 0 multiplied with 1 minus 1 multiplied, 1 to the power cube. So the numerator is 3 and the denominator is minus 1. So it is minus 3. Yes, we are getting a finite value. So we conclude that this limit is minus 3. Okay. The next problem that we are going to see is limit xy approaches 3 comma minus 4 to the function under root x squared plus y squared. Okay, so what shall it be? Here also we will try the same. So under root 3 squared plus minus 4 squared. Remember, it is a well-defined function. So well-defined function in the sense, if you consider this as plus or minus case. Okay, actually in the under root you are going to have 9 plus 16, which is under root 25. So under root 25 may be plus or minus 5. We may think like this, but I have told you people, in the one variable setup itself is that if we take that way, plus or minus, your same value goes to two different values. That cannot be a proper function at all. So when it cannot be a proper function, we cannot talk about limits, differentiability, and all those stuff are absolute nonsense, right? Since this is a well-defined function, it has to be only a positive square root unless it is given with negative sign. So the value is 5. Okay, till now things are going in a very smooth way, right? Now let us move to the next problem and see how it goes in that. So the third problem that we are going to see is as limit xy approaches 0 0, x squared minus xy upon under root x minus under root y. So for which here it is not going to work out. As of now, let us see what is happening. 0 squared minus 0 multiplied with 0 upon under root 0 minus under root 0, it is 0 upon 0. So, which is an indeterminate form. Now you may ask me, can we apply L'Hopital's rule to do it? If you have to apply L'Hopital's rule, you must be knowing how to do the differentiation and multivariate setup. Till now we have not seen it. Okay, it is not gonna work. So what shall be done? Okay, have a closer look at this problem. You may notice something that it involves some irrational quantity. When we try to rationalize it, we may get something, right. So that is the thing that we will try. Okay, since it is a trial and error way, let me write things in different color. Okay, so what I do is that I just consider only my f of xy, that is x squared minus xy upon under root x minus under root y. I multiply with under root x plus under root y upon under root x plus under root y. So it becomes under root x plus under root y multiplied with you. Here you may notice that you may take x outside, so you can take x outside and you have x minus y. Here it is a squared minus b squared, so it is going to be x minus y. Now you may very well cancel these two things. Now you may ask me, is this cancellation valid? Yes, I say that this cancellation valid. Okay, let me write this too. This cancellation is valid since x minus y, okay, that is x minus y equals 0 is not in the domain of f. What am I trying to say here? X minus y is not equal to 0, which means x is equal to y. When your x and y are same, your under root x and under root y are same, which in turn will give you that divide by 0, which cannot happen, right? For the well definition of a function, which cannot happen. That is why we say that this cancellation is valid. Okay, so back to the problem. So what you have is that x multiplied with under root x plus under root y divided by 1, so which is simply this. Now coming to the limit xy approaches 0 0 to this function, okay, that is x multiplied with under root x plus under root y. You may very well see that this is 0 under root 0 plus under root 0, which is a 0. 0 is a finite quantity. Of course, the limit exists. We come to the conclusion that the limit exists. Let us see in the next problem a different kind of a thing.